Hi, my name's Alexia. Welcome to my office hours. What do you have for me today? Okay, so you're having some difficulty understanding or regarding hash tables. So what is your current understanding of hash tables? Okay, once again, no worries. Let's figure this out together. So starting off, what is a hash table? So a hash table is a data structure that supports insertion, removal, and lookup of key value pairs in constant O of one time, meaning that no matter how big our hash table is, that on average, the operations that we do with it will take the same amount of time, constant amount of time. So hash tables require us to apply a process called hashing, which involves 3 steps. One being translation, 2 being compression, and 3 being collision resolution, which if we have time, we will get to that. So let's say we have a hash table or an underlying vertex holding our key value pairs. And let's say 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Let's see. Yeah, 6. So this will be index 0, 1, 2, 3, 4, 5. And so the size of our table is going to be 6. So we're going to have some key value pairs already in here. So let's say, well, let's first define an example. So key value pair. So let's say we are trying to find GPAs based off of unique names. So we're searching by the key, which is unique names. And we're trying to find a value or data associated with that key. And so we're going to say GPA. And so let's say already in the table, my unique name, Alexia M, and I have a GPA, let's be nice, 3.9. And let's say somebody else in the table, Candace, has a GPA of, I don't know, 3.4. So let's say we want to find my GPA based off of this. So the first step is we need to translate my key into a hash value or a hash table index. And so let's come up with a translating function. So given a translating function here, right here, put that into the translating function, we're going to get an index. So let's say our translating function says, if the first letter of your name is an A, we're going to give you a 0. If it's a B, 1, etc. To make this example easy, E4, E, F, 5, and then let's say G, A, B, C, D, E, F, G, 6. All right, perfect. So if we happen to give Alexia, the first letter is going to be A. So putting into this translation function, we should be getting a 0, which is convenient because it happens to be a valid index in our table. However, and so what we get this index 0, and we're like, hey, we go to index 0. I found my info, 3.9 is right here. That's my GPA. But what if, let's see, what if we want to insert, let's see, what if we want to insert the name EFGH, insert the name Henry. So we have Henry. And when we put it into our translating function, we realize we get the number 7, but 7 isn't a valid index in this table. As you see, like we go to 5 and there's nothing more. So what we have to do is do the second step, which is compression, which is basically taking our index and making it valid in our hash table. All we have to do is take the modulo of this with the size of our table. So if we take the modulo, the remainder of 7 divided by 6 is 1. So this is going to bring us to this spot in our table. And then we can put Henry, let's say Henry, I don't know, Henry has a GPA of 4.0. And so that's how we would apply translation and compression to like find or insert items. You can also delete items, and that is also involved with collision resolution. And maybe in another video or at a later time, I can show you how to do that as well. But yeah, so that's how you would be able to use a hash table. And I hope that was helpful because I also struggled with hash tables when I was taking this class.